Hello, everyone, and welcome to TDWI's webinar program. Thank you for joining us today. I'm Linda Briggs. I'm an editor here at TDWI, and I'll be your moderator. Our program today is Modernizing Data Architecture Using Change Data Capture, CDC, sponsored by Attunity. And for our speakers today, we'll first hear from David Lotion with Knowledge Integrity. After David speaks, we have a presentation from Kevin Petrie with Attunity. Before I turn the stage over to David to get us started, let me go over a few background items. Today's webinar will be an hour long. At the end of their presentations, the speakers are going to host a question and answer period. So if you have a question for either speaker at any time during the presentations, just type it in there on your console and send it over. We'll get to as many of those questions as we can at the end of the hour. If you run into any technical issues during the webinar, there is a help area there below your slide window. You can click on that for some suggestions. If you're a Twitter user and you'd like to discuss this webinar on Twitter, please do so. Just include the hashtag TDWI in your tweets. Finally, for a copy of today's presentation, you can download a PDF to your system immediately. There's a line for that on your console. In addition, as always, we're recording today's webinar, and we'll be emailing each of you a link to the archived version later. So you can view the presentation again, or please feel free to pass that link along to colleagues who may have not been able to make it today. Okay, once again, our program is Modernizing Data Architecture Using Change Data Capture. Our first speaker is David Lotion, who is president of Knowledge Integrity, a consulting company focusing on information management solutions for information quality, business intelligence, and metadata management. David is a recognized expert in information management and writes and speaks on the topic frequently, including at TDWI conferences and events. So David, great to have you here. Let me turn things over to you.
Thanks, Linda, and I want to thank TDWI for inviting me to speak on this webinar. I also want to thank the folks at Attunity, and it's great to be able to be working with them on another webinar. We did a few in the past, and they're always great to work with. So I'm looking forward to the opportunity later to answer questions about some of the topics that we're talking about today. And in particular, the title of our talk today is Modernizing Data Architecture Using Change Data Capture. And I think that if we want to talk about the whole question of modernization of the data architecture, we really have to understand what the current approaches to data architecture are and why it's no longer considered to be modern. We also have to understand what the motivations are for creating or modifying our architecture or modernizing our architecture and bringing it forward in terms of addressing newer needs. And number three, we have to look at what the challenges are in getting to that modern state. So that's what I'm hoping to talk about today. And let's kind of start with that first point, which is, what is the old style or the existing or the conventional wisdom associated with data warehousing and analytics integration. We have to start with looking at the sources of data that typically in an enterprise data warehouse environment, we're looking at pulling data out of the data sources that exist within the corporate firewall. So we have data extraction routines that pull data from those data sources, and they might be sitting in some static database. They might be sitting in some system. They might be sitting in some archive. There may even be some different types of data sources, maybe some from mainframes, et cetera, some from relational databases. And we pull those data sets that have been extracted, we bring them to some kind of staging area where we do data standardization and data cleansing and validation and maybe some other types of validation of the consistency of the data that's being pulled from these different sources, because typically they're being pulled from siloed application environments or siloed business functions. At that point, we can do some transformations that modify the data so that it meets some kinds of standards for the data warehouse, and then we reorganize the extracted data into the target model for that data warehouse, and we prepare it for loading into the data warehouse. And typically scheduled in terms of batches. So we'll have a bunch of data sets that have been pulled at a particular time. We run through this whole sequence of standardization, cleansing, transformation, reorganization, and then we load that data on periodic instances into that data warehouse. Now, there's some things to think about or to note about this typical approach. Number one, the sources are originating typically within the organization. We're not looking at data that's being pulled from a wide range of external sources. And a large part of the reasons for that has to do with the fact that we're looking at operational reporting and what we might call descriptive analytics, really saying, well, what is it that's been going on in an organization? How can we provide some reporting about what were the sales by region, by product type, summarizations of existing operational activities, as opposed to looking at types of analytics that are becoming a little more prevalent these days, and that we're going to talk about in a few minutes. That's number one, is that most of the sources are under our control. The second point that we might want to make is that integration is going to be synchronized. We're going to be pulling the data out. We may stage the processes of pulling those data sets into that staging area on that same periodic basis, so that we know that all the data that's being pulled was up to date as of 9 a.m. This morning, and so we've got some type of engineered synchronization of that data. We know that there's some expectation of consistency because of the periods that we're using for those for the sequences of data extractions. The third point that we might want to make is that all that data is available for bulk transfer. Once we've got that data sitting in our staging arena or staging platform, and we do all these sequences of standardization, cleansing, et cetera, all the data is there so that we can schedule batch loads and do bulk transfers into the data warehouse. So we can kind of gate the sequences of moving data sets from their original sources ultimately to that data warehouse, so that we know that there's some kind of control over synchronization. That's the old approach, and that's what we might say needs to be modernized. And the reason that it needs to be modernized is that we have a different type of environment these days, and this is what I've been calling and sharing with folks, this concept of the extended information enterprise. And this extended information enterprise begins with what we saw on that last slide, which is data sources that originate within the different business functions inside your on-premises environment, behind your firewall, we might say, where the data is being pulled out and in lockstep is being loaded into a data warehouse. But that is now only one piece of the environment that we are using as our broad scope for bringing into our analytics and reporting and analysis processes. We also have partner data sources. So now there's a greater interest in sharing information with partners, that sometimes organizations are operating on applications on behalf of their clients. They're able to pull some of their own data and share it with the organizations that are their customers. For an example might be a company that's running a call center for you. They can provide information about what was being requested by the people who are calling into that call center and the operations that the people in the call center have been doing, and then push that data back to your organization to then load into your own data warehouse and merge it with information about your products and your pricing and customer support and those types of things as well. So we've got partner data sources. The third aspect of this extended information enterprise is a growing pool of what we call things that are generating data. So if you think about the concept of the Internet of Things, IoT, we've got all sorts of devices and machines and sensors that are embedded within these dynamic networks that are generating data streams. So examples might be appliances, energy meters, power meters, social media networks like Facebook or LinkedIn or Twitter, embedded sensors within machinery in factories, embedded sensors within trucks in fleets that are being run by organizations. So all these machines or things are integrated with their own collections of smaller devices that are perhaps in some cases continuously generating data feeds or data streams that can be pushed out into a network that can be then forwarded to different sources, different destinations within that network. And finally, there's an increasing interest in using cloud resources for doing your computing, whether it's using your cloud resources that are under your own control, such as your own data lake that's being managed in an HDFS environment that's running on Azure or on AWS, or even additional levels of hierarchy where you're working with a host provider they're running some application that is layered on top of cloud resources, and they're managing an application on your behalf. So, a classical example of that might be a Salesforce automation like Salesforce.com, where that's an application. There's a lot of operations that are being done there. It's running on top of a hosted environment that may be running in the cloud, et cetera. So we've got these 4 different environments, or these 4 different districts where data sets are being created, generated, communicated, et cetera. And in fact, we have the need to share information across and among all of these different environments. So we're getting partner data, and some of that partner data is being brought into our on-premises environments and loaded into our on-premises data warehouse. But maybe some of that partner data is being moved into a data lake in the cloud that we're managing, so we can share that data with some of our other applications. Or maybe we're getting streaming data from IoT devices, and that's being loaded into an analytical engine that's sitting on top of a Spark application that's running in a cluster sitting on Amazon or in some other cloud provider. And then maybe we're pulling the results of those analyses and bringing it back into our customer profile sitting in our own data warehouse on premises. Or maybe we're forwarding profile information back to our partners. So we've got all sorts of need for sharing data across these different arenas within the extended information enterprise. And so because of that, those are some of the new motivations for modernizing the data architecture. We have to look at this in a little more detail about streaming data. So I talked a little bit about IoT devices. Well, these are all data producers, and here's some more examples of data producers. We've got autonomous cars or non-autonomous cars are generating data. We've got all sorts of different apps, but transportation, trains, trucks, cars, automobiles, airplanes, constantly generating data. Power, utilities, oil rigs, pipelines, appliances within your own house, the integration of a wide range of different types of devices that are sitting in factories, vending machines, et cetera. These are all being connected with internet capability and the ability to stream information. And so we have to think about how these data streams are integrated within your environment. So here's a kind of a typical map where we have our data producers, and the data that is being generated by those producers is collected by what I would call a data collector. Sometimes those are all sitting in the cloud. Maybe there's a hierarchy of those nodes. You may have edge nodes sitting in your factory that is collecting the information from each factory line, and then another one that's hierarchically placed on top of all of those, et cetera. A lot of those are being pulled and collected by these collectors, which then forward the data to these processes that will ingest and maybe cache and then distribute that data to analysis applications. So at that third column from the left, maybe we're collecting that data and dumping it into some temporary location, which then does a little bit of filtering and pushes it through into these analysis engines. Some of that, the results of those analyses are persisted into a database somewhere, but some of that as well, some of those analytical models are pushed back into the environment. So perhaps they're created as some kind of monitoring devices or monitoring models that are used for decision support at different places within the network. So maybe that's being placed back into an app that's sitting on a mobile device, or maybe that is being used for supporting recommendation engines on a website, or maybe it's being pushed out to the nodes of the different customer services and support centers, or maybe there's analytical models that are being pushed into the factory network to monitor for imminent device, or part failure, so you can do predictive part replacement. Or maybe some of the information is coming from the weather services and the news and the traffic being collected and merged with data that's being generated by all the trucks in your logistics fleet, so that you can provide some real-time information back to the drivers to modify the routes that they're taking so that they can deliver their materials on time, et cetera. So this whole concept of being able to learn from the streaming data that's coming from all your different devices to inform analytical models that then can help in influencing decisions that then are being made back at the originators of those devices is becoming a general desire among organizations that have the interactions with this broad range of data producers and then consequently analytics consumers that are naturally adapted within that extended information enterprise. And so this is another aspect of the motivation, which is we want to have integrated analytics up from using the data that's being generated by a wide range of different devices and be able to manage all that data. And that's way different than what we were talking about earlier in the concept of the old-style data warehouse analytics integration, where we have lockstep or staged or synchronized data extractions, integration processes, and then loading that data into a data warehouse. That's no longer operational because the data is not being generated in lockstep, but it's being generated dynamically all the time. So there are some specific challenges that we have to consider, and the key here really is data integration. It's really not a question of do I have a good endpoints for our IoT network, or do we have streaming engines that are filtering our data, but rather those are all different aspects of a more general approach or concept of data integration, which is not what we used to call ETL, extraction, transformation, and loading, but rather all aspects of data integration, which really mean being the provision of information that is derived as a result of a sequence of processing across a number of different stages in an information flow in a hierarchical web or network of data consumers, data producers, data forwarders, filtering, et cetera. So we have to look at each one of these aspects here, and these bullet items are really just a subset of a much broader collection of challenges associated with the end-to-end data integration. The first is source variety, which is when you're looking at data sources that originated within the business functions within your own organization, you have had control over how those applications were designed and engineered and built and implemented, so you have some control over what the output of those systems looks like. In the extended information enterprise, especially when you're looking at IoT devices, you've got all sorts of devices generating data in different types of formats. The structure of that data is different, and the speed at which those streams are being generated all introduce complexity into the ability to do integration among a variety of different formats, et cetera. The second bullet item is the need for scalability, which is we've got, instead of having 10 different systems that existed within your environment that you had to deal with, you've got dozens or scores or hundreds or possibly even thousands or tens of thousands of different types of data sources that you would like to be able to handle coming into your environment. So, maybe if you're a large organization, you've got all sorts of different sources of information. A good example might be in a telecommunications business where you've got a large number of different services that you're providing. Perhaps you're providing mobile telephony, you're providing landline telephony, you're providing internet service, you're providing entertainment services like streaming entertainment channels, and you've got all sorts of other aspects of your business that have to do with provision, such as the people who are going out into the field and running wires and installing pipes and et cetera. You've got all sorts of different devices that are out there in your network that need to be managed and monitored. And so you need to be able to scale up. And so the number of data sources can overwhelm the performance of those conventional architectures. Number three is timeliness. In our traditional conventional architecture, we can control the synchronization of the extraction of the data from those sources, and we can do it in certain blocks or in a certain cadence, so that allows us to enforce some level of synchronization and coherence. But these streaming data sources need to be integrated in real time. There's no way to control. You can't say to a device that's sitting on a robotic manufacturing arm in an automobile factory, you can't say, okay, now stop for the next hour and don't generate any data while we collect it and install it, or load it into our data warehouse. That data is just going to come whether you're taking it or not. So you have to be able to identify those streaming data sources, be able to understand the speed, the velocity aspects of how frequently the data is being streamed, and then how you can integrate that in as close to real time as possible. Number 4, I made this point before, that data integration is not just about getting data and loading it into your data warehouse. Data integration also includes the ability to provision that information back to the people who need it. So you need to simplify data consumption. And again, the complexities is not about being able to get access to a data source. It's being able to get access to the combination of all the data sources that we talked about in bullet item, the first bullet item, the second bullet item, that we have, scores, dozens, hundreds, thousands of data sources, and be able to deliver some kind of coherent view to the application developers and the data consumers who really want to know, how to build that into their reporting and analytics. And the 5th item here is about the agile development methodologies, that if information is streaming much faster and it changes with greater velocity, then we need to be able to handle that. And so I use Agile with a capital A in talking about the Agile development methodology and how that's being done. But we have to understand that there's a lot of aspects of that development methodology that focus on the creation of the product that don't take into account the complexity of the information that is being used to fuel the use of that product. So we have to not only be able to rapidly adapt to changes in the environment and different kinds of motivations, but we have to be nimble in responding to dynamicism in the data sets themselves, that your devices may get a refresh or an update that changes the format of the streams that are coming out of those systems, but you were never notified because nobody really knows who the consumers are. They just update the operational aspects of that device, and it's up to you to figure out that it's changed and that you need to do something about it. So these are some of the challenges, and I think I could summarize some of these in saying that the biggest challenge here is that we're going from an environment where we had a large degree of control over the times at which we're pulling that data and how we're loading it into our environment, to one where we no longer have that level of control. So I want to talk about the use of this concept of change data capture. Change data capture is not a new technology. It's a technology that's been around at least 20 years, maybe more. And it's a method for identifying modifications and updates to existing data sets and being able to forward those modifications incrementally to the consuming environment for that data, instead of looking at blocked and bulk data movements from one data set to another. The idea here is that it was originally developed, and I guess Kevin maybe can correct me if I'm wrong in some way, but I believe it was originally developed for synchronizing data updates with replicas across different networks, sometimes geographically diverse networks. And I'll say from my own personal experience in the mid-'90s, when I was working in the financial industry, they were doing data replication, and because they had offices in New York and in San Francisco and in Los Angeles and in Hong Kong and in Shanghai and in different places in Europe, and they were making updates to the data sets, and they wanted to the databases, and they wanted to make sure that there was rapid access to that data in those different geographic locations. And so they used the concept of data replication, where they basically had updates being made in one location, and those updates were incrementally identified and forwarded relatively quickly to the different satellite locations, so that everybody saw within a particular time frame, they saw a consistent view no matter what office they were using. So change data capture was the process of being able to identify when changes were made and be able to pull those changes and forward them in a much faster manner than just waiting for the next period to do a bulk upload of that data. But the idea here is that this concept is, just because this concept is not a new one, it's one that has matured in many ways and has been adapted in many ways to what I was referring to as the extended information enterprise, which means that we no longer have to look at change data capture as being limited to just pulling changes off of a relational database, but rather any scenario where we can be monitoring for changes in some data asset, be able to identify what those changes are and be able to forward those changes to the different consumers in that information network. And again, I'm talking about it in terms of it being a network and not just as a sequential flow, because we have a lot of different consumers who are looking at the data coming from a lot of different places all simultaneously. And here, basically it's a tried and true mechanism that we can adapt to the extended information enterprise. So what we're doing here is looking at how the data streams are really subjected to multiple processing paradigms, not just taking data out of a source and loading it into a data warehouse, but rather we're taking data from a number of different sources and loading it into an operational data warehouse. We may be taking that data and loading it into a reporting system. We may be forwarding it into some kind of cloud-based analytical environment that is looking to create analytical models that can then be used and integrated within the network. And then we can do so there's the analysis and the modeling that will create these analytical models. And then there's the analytics that are integrated within the environment where you take those analytical models and push them back into the network. So we can say, here's all the data that comes from trucks. We do some analysis and say, oh, well, when these sentinel events are taking place, there's some indication that there might be an imminent failure of an oil filter. That becomes a model that is then put back into each truck and then is continually monitored. And when those sentinel events take place within the network, it sends some message to some action that will then notify the driver that they should be driving over to a particular service location that's within 50 miles of where they are. We'll arrange for the part that needs to be replaced, be FedExed to that location, so that when the driver arrives there, it can be replaced instead of there being some kind of failure in the middle of nowhere. That creates a much greater delay in the delivery of the items that are on the truck. It's just an example. So what it basically says is multiple simultaneous applications that are working at the same time that want to get that data, and yet the volumes and the velocity of that data coming from all these different locations in the extended information enterprise are going to strain the conventional approaches to data integration, where we're just dumping it into some kind of staging area and then waiting for some sweep application to run the transformations and reorganization and bulk loading it into the target data warehouse. So really, what we're looking at is how we can reframe our thinking to make use of a technology or an approach like change data capture to this modern environment. And you really want to think about, are we looking at a data source as being a database, or are we looking at all data sources as being some aspect of a stream of information as information changes over time? And instead of trying to do more the conventional approaches of bulk data transfer, rely more on incremental integration of data, which ultimately is going to relieve those pressures that we talked about in slide 7, the need for scalability, the need for timeliness and synchronization on the fly, the need to simplify data consumption, the wide variety of those data sources. And so here's some ideas here. The first is to configure data streams to forward incremental changes to multiple consuming applications. So as we said, we've got multiple applications that are operating all simultaneously that all need that data. We can use change data capture as essentially a way to identify when there are modifications to the streams or modifications to a data asset and forward those changes to more than one target in that network, but rather in the web of the different applications that are pulling that data. Number 2, using change data capture is going to reduce data latency, because if we're not doing bulk transfers inside this network, we're not flooding our network with these huge data sets that are going to reduce the speed of being able to deliver information. So instead of we're using incremental changes using CDC, we keep the network relatively free of these large bulk transfers, and so data latency is improved. We get the speed of data delivery becomes much faster. And therefore we're reducing latency and we're getting the data to be available much faster. But we also are able to publish that data to a wider variety of the consumers at the same time. So instead of taking the data, moving to the staging area, doing some stuff, and then loading to the data warehouse, and then letting users get access to it, we can actually, at the same time, use CDC to pull the data incrementally and forward it to all the applications at the same time. So you don't need to wait for it to be gated through those different sequences in that data flow, but rather you can make that data available much faster. Therefore, you don't have these batch windows where you have to wait for the data to be available. And instead of by doing that, it allows your applications to be somewhat more nimble in terms of being able to make use of that information to inform decisions all across the network. And so that changes a little bit the way that we look at this information flow. The big change here is where we've got our ingestion and caching and distribution is that we have some kind of staging. I'm not going to use the term staging. We have some kind of storage location where that data is delivered, but once it gets delivered there, the change data capture is continuously monitoring when that information collection is being modified. Then it can pull that data to simultaneously push it through different sequences that can do the analysis, which then push the results, the analytical results, to the different consumers. So in that operate and act, we've got all sorts of different updates being done simultaneously that are then feeding different types of decision processes that could be then pushed back or integrated within the entire network, not just delivered to one centralized data warehouse. So an example would be streaming IoT data that's fed into a data warehouse on premises. So we have, let's say we've got data that's being pulled from some of these different devices and loaded into an on-premises data warehouse. But we can have a change data capture agent that's sitting on premises that's monitoring updates to the data warehouse and pull that data in real time and push it to our hosted cloud environment. So pushing data to the data lake or feeding some kind of ongoing analysis that's being run in parallel on a cluster, or loading the data into some kind of persistent storage on the cloud, or running some kind of application that's providing data services for immediate queries that's being done. So we can forward that information that's being loaded into our on-premises data warehouse to the cloud-based analytical applications and the data lakes and make that data available in real time, as opposed to having to pull that data on a periodic basis out of that data warehouse. And again, this was just a simple example. You can look at it in any direction. We have the streaming IoT data going into a data lake, and instead of having to change data capture sitting on premises, we have it sitting in the cloud, which then pulls the data out from the data lake as soon as it gets there and pushes it to an on-premises data warehouse, but also pushes it to another cloud data warehouse, or maybe pushes some of that data back out to some other devices so that it can then feed the integrated analytics that are sitting in those different environments. So an example there might be monitoring energy consumption across a network, of a utility network, and seeing that if there's a particular stress that is emerging, that we can pull the data out of that data lake and push it to individual controlled devices and in residences that throttles energy use of individual compressors that are being used for air conditioning, so that you can have some kind of control within the environment that's being monitored in real time, and we can use CDC to kind of power that. So that being said, here are some things to consider. At what point can conventional data integration be combined with change data capture to provide real-time or near real-time integration, where we're actually combining the use of CDC with embedded capabilities for doing standardization and data validation, and doing that almost as a switching network for forwarding information to the consumers. Number two, can a CDC solution enable data services that dynamically adapt to a changing array of data sources, so making data available from those different sources as soon as possible? And then how do you use change data capture to streamline real-time operations and simultaneous analytics? So These are some things to think about. I think Kevin's going to talk about some of these ideas. And again, I want to thank Linda and TDWI for giving me the opportunity to chat about some of these ideas today, and Attunity for sponsoring the webinar. I'm going to hand it back to Linda.
Hey, thanks, David. Just a quick reminder to the audience before I introduce Kevin, we welcome your questions. So if you have a question for Kevin or for David, go ahead and type it in on your console, and we'll get to as many of those as we can toward the end of the presentation, right after Kevin speaks. So next up is Kevin Petrie, who is Senior Director of Marketing at Attunity. Kevin has 20 years of experience in technology with a focus on big data and the cloud. He has held leadership roles with EMC and Symantec, and prior to receiving his MBA from Haas School of Business at UC Berkeley, Kevin was a financial writer with TheStreet.com, analyzing the data networking and telecommunications industries. So Kevin, great to have you here. Welcome.
Thank you. Thank you, Linda, and thank you, David. Great stuff. Very pleased to have the opportunity to share with you some of the trends and decisions that we see your peers, other data practitioners, data engineers in particular, making as they navigate this changing world of data architectures. So what I'm going to do is talk a little bit about, from the customer, from the enterprise perspective, what are some of the primary challenges that we see, and this will line up nicely with what David was walking through in terms of challenges with traditional data integration tools. These are 4 examples with actual enterprises, Fortune 250 enterprises that we work with. And they were using traditional batch-oriented replication tools in order to copy data from a production source, a production database in a lot of cases, to an analytics target. Because a lot of the architectural considerations and so forth that David was walking through really boil down to putting timely copies of data on a separate, dedicated analytics repository. So the first customer here is, or the first enterprise, was unable to extract data and decode it rapidly enough from SAP, Enterprise Resource Planning, ERP applications, and PeopleSoft fast enough in order to put it into a data lake for timely and relevant analytics. We have another enterprise here. This is a major organization in the food processing industry. They had nightly batch jobs that were failing to reconcile orders and production line data on time, which meant that you had the one side of the business, the sales side of the business, out of sync with production. They process and sell tens of millions of chickens a week, and those chickens were not being processed quickly or in a synchronized way with demand. So that slowed plant schedules. It prevented accurate sales reports. Another example here is with an organization that is based in EMEA, and they are one of the world's largest payment processors. And using old tools, actually using, I shouldn't say old, it was Scoop, batch-oriented methods of moving data into a data lake, they were unable to process transactions quickly enough. And in fact, that cost them margin on every transaction because they were unable to rapidly assess customer credit checks in-house. They had to hire a third-party agency in order to perform real-time credit checks. And as a result, they were losing that margin because they had to pay someone else to do the credit checks that they had the data themselves to do. The final example here is a company also in EMEA that is an insurance provider, and they had a number of siloed batches of data that they were unable to break down because they simply couldn't process enough batch data quickly enough. And as a result, they had different stakeholders. They had different versions of the truth when it came to customer records. Customers and sales had different views of their own data. Other stakeholders, such as partners, had their own views of data, and you had this real disconnect that led to frustration, declining customer satisfaction, and inefficiencies. So change data capture, which David talked about, has been around for a while, but it is something that we've had a role in leading the adaptation of that technology to new modern environments. CDC can enable faster and more accurate decisions. So that's something that I think makes intuitive sense. People want data to be current. The notion of real-time analytics is gaining a lot of credibility and a lot of investment in the enterprise community, as it should. Another advantage of CDC, which might get overlooked in some cases, is that you can literally eliminate that disruptive batch window in a lot of cases by non-disruptively looking into backup and recovery transaction logs on source databases, identifying real-time changes, and then sending those copies at near zero latency to a target. You're not touching production workloads. You're not intruding on production workloads in order to do these long batch jobs that slow everything down. You can get rid of that effort. You can simply lightly copy the real-time deltas and send them to your target. Change data capture, by just sending the deltas instead of repeatedly copying unchanged data, can reduce the bandwidth consumption and thereby the cost of moving data over the wide area network to various cloud targets. So those are three key things: the real-time nature of the decisions that you're enabling, the elimination of the batch window, and then the streamlining of data by just focusing on deltas rather than unchanged data as you move it over the cloud. CDC, for these reasons, is really taking a leading role, and it's a foundational aspect of modern data architectures. The Fortune 100, Fortune 1000 enterprises that we work with have three fundamental shifts that are literally changing the ground under their feet when it comes to data architecture. The first is the data warehouse. That traditional single source of truth is being complemented by, or even replaced by in some cases, the data lake. Now that's a complementary sort of symbiotic relationship where data lakes might well become a normalization or transformation zone for ultimate analytics in the data warehouse. But regardless, the data warehouse no longer stands on its own. You've got data lakes that'll cost effectively bring together widely varied and high volume sets of data for very efficient processing and analytics. There's also the shift from batch to streaming. And I've talked about that from a CDC perspective already, but there's no question that there is a desire to stream incremental data from source to target so that you can synchronize data sets across different repositories without repeatedly running batch jobs that have unchanged data. And then, of course, there's the mainstream embracing of the cloud to create these hybrid environments. On-prem data centers will not go away anytime soon, but the need for ultimate data mobility within cloud and hybrid environments is here to stay. So if we look at CDC and kind of cast it against these fundamental shifts and these targets, you can see that CDC is going to layer on top of or extract data from source databases. It's going to replicate it to a database, perform or complement extract, transform, and load, or potentially extract, load, and transform to processes to a data warehouse. It'll help data lake ingestion. And then you can also have CDC become a publisher to Kafka, to Amazon Kinesis, other streaming platforms. So all these things could exist on premises, in hybrid environments, or in the cloud. And those are the 5 primary CDC scenarios that we enable with organizations. And so what we find is that a lot of organizations are on a maturity curve, a maturity model, if you look at it this way. We see 4 primary levels. There's basic, where there's a desire to copy data from production to an analytics target, and they're doing it with the more rudimentary tools that are manually doing full load replication. They still have data silos. They can't get everything integrated in a timely way. They're taking up a lot of ETL programmer skills, and they have a high dependency there. They're impacting production. They got to figure out when to, during the middle of the night or on weekends, run those disruptive batch jobs. And there's a lot of ETL scripting, so it's not easy. Level 2 is more what we call opportunistic, where people are starting to realize, okay, this CDC technology is going to help me do things a little more efficiently. And so they're starting to have these incremental advances in terms of the way they operate, improvements to efficiency, starting to reduce the impact on production operations, A lot of the rudimentary CDC tools will use agent-based technologies where they're going to install a software agent on every source, and that's going to it's going to divert resources from production workloads. Levels 3 and 4, things start to get interesting, and this is where we see a lot of organizations starting to move today. Level 3, systematic in particular. Here, there's an embracing of CDC. There's the use of automated solutions that eliminate the need for manual coding. There's an embracing of agentless architecture or zero-footprint architecture where you can remotely scrape those change logs, identify and capture source incremental changes, and then send them to a variety of targets. Maybe you're going to publish it to Kafka. Maybe you're going to do some real-time ingestion for land to get into a data lake. You can have multiple styles and multiple types of endpoints. Maybe you're integrating with microservices environments. Here, the data is becoming more and more integrated. You've got ideally one or just a few processes for integrating data, and you're automating in order to eliminate or at least reduce that dependency on ETL programmers. And we can enable this with Attunity Replicate and Attunity Enterprise Manager, which I'll talk about in a little bit. Level 4 transformational. We do have some customers here. This is the bleeding edge. It's really automating fully the CDC process and the data integration process across a multi-platform environment, and is starting to apply automation to data structuring processes as well. So you can further reduce the ETL scale requirements because you're automatically creating and updating data stores, for example, in a data lake. You're automatically creating and updating and managing data warehouses. You're going to have a very low production impact because you're really just copying those incrementals and not creating a production workload or a disruptive batch job. So Attunity Replicate and Attunity Enterprise Manager play here, as does Attunity Compose, which will provide that automated structuring process. So who is Attunity? What we do is we provide the leading platform for delivering data with high levels of efficiency and real time to those new disruptive architectures, data lake, streaming, and cloud. So we're the #1 independent provider of CDC. We support really all the major sources and targets, all major databases, data warehouses, cloud, Hadoop, streaming, legacy systems. And we're the #1 database migration technology for the cloud. So we've moved over 55,000 databases to cloud platforms like AWS. In fact, we're the preferred cloud provider to Azure and AWS. We're #1 in ease of use, so we will fully eliminate the need for manual ETL coding. And that means that data architects, people who know the environment but don't know coding necessarily, instead of DBAs or developers, can perform those data integration tasks. And so the platform here includes Attunity Replicate, which is that platform, that single process, that single fully automated process for moving data from point A to point B via CDC and via full load to kick things off. Attunity Compose, which will automate that creation and updates of analytics-ready data structures. And Attunity Enterprise Manager, which is the umbrella offering to manage all of this in an automated way at scale, so that you can look across potentially thousands of replication tasks across large heterogeneous environments and manage all of that in a very efficient way. So with Attunity Replicate, the investments we made, the value is focused on simplicity, prepackaged automation of all those complex tasks, no agents, zero source footprint, very intuitive user experience. We've got the real-time CDC, and we've got the universal coverage, as I mentioned before, where we're supporting all the major platforms across these categories. We will support SAP and very easily decode data from source SAP data structures for usage on external platforms. And what I want to do now is quickly talk through 3 case studies. This is a household name. I can't name them, but they are a household name that probably is managing a lot of your retirement money. And they have $1 trillion assets under management. What this organization sought to do was synchronize an on-premises DB2 ZOS mainframe system that had over $1 trillion of assets under management, and they needed to, on an ongoing basis, reconcile trading, updates, and redemptions and so forth within that to users across the globe. So Attunity Replicate is publishing, or I should say running CDC, change data capture, non-disruptively on this DB2 ZOS system, sending the incremental updates to the AWS cloud. At that point, the data will be run through a DynamoDB stream system, and this enables a microservices environment where you've got clients all over the globe, maybe in Europe, maybe in APJ. There are regional hubs in London and in Australia. And all these folks are using hundreds or maybe thousands of different microservices to manage and update their accounts. And they're doing it with real-time data that we're publishing throughout the AWS cloud. Another example here actually alludes to the food processing company with the need to process all those chickens and get them to dinner tables all over the country. They're extracting data from 10 tables within SAP ECC. They're publishing to Kafka, which publishes to a data lake. And at that point, with the Hortonworks data lake, they're using a few different types of processing engines, including Spark, in order to combine the production capacity and customer orders on a real-time basis and thereby improve manufacturing and get things in sync throughout the production line and the supply chain. Now, this example is very interesting because we have this is a pretty advanced Fortune 100 pharmaceutical firm that is using us to publish real-time updates to clinical systems to Kafka, which is then streaming data to a Lambda architecture, which is a fancy way of saying that you have this batch processing and real-time processing of different types of data. And that Lambda architecture is supporting machine learning use cases, which gets to really new ways of understanding data patterns and new ways of self-teaching to identify and act on those. We've also got graph analytics and natural language processing, where they're using natural language processing in order to more easily identify takeaways from thousands or millions of records of doctors' handwritten notes. So a lot of very interesting stuff going on here. It really all starts with Attunity Replicate CDC publishing to that Kafka stream. The final point here is we've got this Fortune 100 health benefits firm that is using us to create that 360-degree customer view from a lot of these traditional systems, Oracle, SQL Server, and mainframe. Again, they're using us to publish to Kafka, which again within a Hortonworks data lake is much more easily creating that single source of truth about customers for a variety of different analytics use cases. Really appreciate the time to share these stories with you about what your peers are doing. We'll look forward to questions. I want to note that a lot of the themes here are in a book that we wrote and published just last month, which is Streaming Change Data Capture, a Foundation for Modern Data Architectures. We would look forward to your review and any questions or feedback on the book. So, Linda, I'm going to hand it back to you and see if we have any questions.
Great. Thanks, Kevin. Yeah, I'll leave that up on the screen for a minute here as we move into the Q&A, but let me start with an audience question here. I'll hand it to David, and then Kevin, welcome your thoughts as well. Someone's asking about CDC when you're talking about videos, images, or unstructured data. So what does a delta or incremental data look like for images or unstructured data, David? And how do you check in real time for the changes when you're doing CDC?
So I think we have to reframe that question, which is, what is it that is our objective for processing data artifacts that are not structured data artifacts, but rather what are we doing with that, and then how does that look at how does that appear as a change or a modification in a data stream. So if we look at it, here's an example would be we've got a Twitter feed where people are posting some text along with some images, and a modification there is the appearance of that, the first appearance of that text or the first appearance of that image, even though other people might be then taking that same collection of words and a graphic, and a picture file, again, retweeting it or reposting it or cross-posting it to Facebook or one of those things. So the fundamental thing that you're monitoring for when you're talking about a change is there what's the first time that this item appeared, and when you see if you've got your processes for analyzing images along with the combination of images and text. When somebody reposts that, for example, they may say, hey, this was really cool, and then repost exactly the same text and exactly the same image. So the modification there is an augmentation to the text stream that came along with that image, or maybe somebody took that image and added some layer on top of that as well, which you can do a comparison of the file itself to say, does it have the same name, does it have the same bit stream, et cetera? Is it been significantly modified? So I think fundamentally, you have to, when you ask this question, you have to rethink it or reframe it in terms of what is it that you're trying to do with that. So if you're looking to take an image and push it through some kind of image processing to do facial recognition, if you've got some kind of signature associated with that graphic image, you can determine whether there's been a modification or not. And same thing for a video or some of those things. But I think in general, what we're talking about here is not specifically looking for incremental changes in a 30-minute video, but rather modifications that are relevant to a particular business process that would involve the processing of those artifacts. And again, I'm kind of speculating there, but I'll throw this over to Kevin and see what his opinion is.
No, I think you've summarized that well. I wouldn't have anything to add there. And so we have some other questions coming in, which is great.
Yeah, let's jump to something else then, Kevin. How's this one for you? How does CDC work with streaming technologies like Kafka and Kinesis? You mentioned those.
Sure, and yeah, actually, there are a couple questions like that. So essentially, we are a publisher to Kafka. We're a publisher to Amazon Kinesis, which means that our CDC will identify and scrape those change logs in order to identify and capture real-time changes and turn them into messages that are sent in a message stream to Kafka message brokers. In turn, we'll send those messages to various consumers. And we'll do it all. I think there's another question here about avoiding ETL. We'll do it all without the need for scripting, because this is a fully automated process to identify your source, identify your target, in this case Kafka or Kinesis, and configure the CDC capturing and the creation of that message stream. And I know I'm jumping in here, but there's also a question, I don't see how you can avoid ETL when you need ways to homogenize the data. We don't avoid ETL. What we will do is our solution will completely automate the extraction and loading process with some light transformations. So we will eliminate the need for ETL scripting. A lot of the transformation, the heavy transformation, is going to take place on the target. We can also automate some of that without Unity Compose.
Right. I mean, basically, I'll jump in here also. What you're suggesting is that we're changing our approach to integration and transformation from being a fundamentally staged approach where you dump the data and then you do all your transformations and then you load. So that's the ETL, to what some people refer to as ELT, which is that you load the data and do your transformations in place. And if you're doing it in that approach, which is much more beneficial if you're trying to do real-time forwarding of data, because you can make the information available much faster, and whatever transformations you need to do, you can do that in place. But what that effectively does is it splits the types of integration tasks that you do to be some that can be done on the fly as you're moving the data, essentially embedding it or integrating it with the CDC. And the second part of that is that you're doing your more complex transformations in place, so you're not creating additional artificial delays in making that data available.
Yeah, thank you, both of you. Maybe run over a little bit here with a question on, can you clarify why I should use CDC if I don't do real-time analytics? Kind of a broader question. Kevin, you want to take that one?
Sure. Yeah, I think the natural assumption is real-time is the primary value and the reason for CDC. The reality is that getting to true real-time analytics is something that not a lot of organizations are doing aggressively right now. A lot of people are getting there. But the idea is that CDC is just a vastly more efficient way to copy data. It's a vastly more efficient way to integrate data for analytics because you can, the two big things are eliminating the batch window, which slows down production, which is increasingly inconvenient in today's global 24/7 environment. And you're also streamlining the amount of data that you need to send over the wide area network to a public cloud target. Those two improvements in efficiency translate to real dollars saved for a lot of organizations, even if they don't need up to the second data on the analytics target.
That's a great answer and a good point to wrap up. Thank you, Kevin. So we are officially out of time here. I want to thank our speakers. That was Kevin Petrie with Attunity, joining David Lotion with Knowledge Integrity. Also, thank you again to Attunity for sponsoring today's webinar. I do want to remind everyone that we recorded it and we'll be emailing each of you a link to the archived version. Please feel free to pass that link along to colleagues. And finally, just a reminder that TDWI offers a wealth of information, including the latest research, reports, webinars, and information on business intelligence, data warehousing, and a host of related topics. I encourage you all to tap into that expertise. It's all at tdwi.org. And on that note, from all of us here today, thank you very much for attending. This concludes today's event.